Hello and welcome back to another Unity Tiny video. In this video, we will be adding in animations, input, and physics for our main character. The first thing we are going to do is create a new entity to hold our character. So we'll create an empty, we'll call it player, and on this entity we'll add a transform node component with a local position and a scale. We'll need the local position for moving the player and the scale for changing the direction that the character's facing using the X scale. Now let's add in a component to show the character. You can show the character with a sprite 2D renderer, and then just go to your graphics folder, find your adventurer. You can increase the size of your icons using this, and then just drag in one of the sprites of your adventurer. You'll notice that you cannot currently see your player because you need a layer sorting, which you can add by clicking on the families and add layer sorting. And here, in the last video, we talked about the layer we would put our player on, so let's go back and look at what layer that was. So we have our clouds back on 0, clouds front on 1, background back on 2, background front on 3, tile map background on 4, platform is on 5, foreground is on 7. We want the player to be in between the foreground tile map and the platform tile map. So we'll put our player on 6. You'll see putting him on 6 makes him appear on the screen. Let's just reposition him a little bit. Now, to make it where he can fall down and land onto the tile map, we'll need physics for the game. To add in physics for your tile maps, in normal Unity, the physics is pretty much added in automatically when you draw the tile maps in and you add in a physics component. But in Unity Tiny, you have to overlap the physics with a collider. I'm sure later on in the future they'll change this, but for now, you'll have to create an empty. We'll call it collider. Add a box collider to it. Then on the box collider, leave your pivot at 0.5 and 0.5 because currently there is a bug within Unity Tiny, and if you change the pivot, when you click play mode, your collider will not be in the same position as what you see it in the editor. So let's change the size of our box. We'll try 14 on the X. Also add a transform node with a local position. Now we can move it over to here. And since at the moment there's no way to get below the bridge, we can just use one collider all the way across all of this. But of course, you could make multiple colliders and position it in the 3 spots where you would assume the colliders would go. But for now, we'll just use one collider. After adding the box collider 2D, you'll want to add a rigid body 2D with a static body type so it does not fall downwards. Then on your player, do the same thing. Add a box collider 2D, position it around your character. The pivot on the Y is usually fine to change. From what I've noticed, the bug comes from changing it on the X and not the Y. Then add a rigid body to your character. Make the body type for your character dynamic and turn on freeze rotation so your character does not fall over. Let's click play and make sure this works so far. You can see our character spawned onto the screen and fell down onto the other box collider. Now, let's add movement in for the character. So, we have the physics added in where he falls and hits the tile map and does not fall through it, but let's make it when you push A and D, you'll walk left or right. So to do that, we'll go into our components folder and create some new components. We'll create a component called player input. Then we'll create another component called movement. And we'll make one more component called flip scale. The player input component will be a fence to capture our input and send it to the other systems. The movement system will be for moving our character left and right, or for jumping. The flip scale component will be for changing the X scale of the player to face left or right. If you put your X scale on -1, you'll see that you're facing the other way. Alright, go ahead and add these components to your player character. Now, on your player input component, you'll want to add a vector2 component, or field. We'll call it axis. On your movement, we'll add a direction using a vector2. We'll add a int8 for speed. We'll add another int8 for jump force. And then we'll add a boolean for jumping. Oops. Now you can see on your player, your movement has a direction, a speed, jump force, and a jump field, and your player input has an axis. Flip scale will just be a tag to let the system know which objects should face the other way when changing their movement direction. The reason that we have movement and player input separated is because we could use this same movement and flip scale component on a AI controlled character and then make a new component called AI input and then derive inputs through code to power where the AI should move instead of it being controlled by inputs from your keyboard. Now, when you put the input into your system for the rigid body movement, you'll need a velocity 2D to actually move the character. Now that we have our system set up on the character, let's reorganize them a bit just for it looks better. I like to put my physics components at the bottom. So we'll move the rigid body 2D and the box collider 2D down. Then we'll put the velocity 2D as the last one. The flip scale can stay here. Alright, I like that ordering. So the next thing we'll need to do is actually create the script systems for this game. So go into your script folder, we'll create a player input system. So go to create, tiny, Typescript system, call it player input system. Open that up. The IDE that I will be using is Visual Studio Code. It's pretty much the same thing as Visual Studios, but a little leaner and with a bit of a different color scheme. Then inside of our player input system, we'll want to say this.world.forEach. The components that we'll be needing are the game.playerInput and the game.movement. We'll name these components as input and movement. Then inside of here, we'll say if ut.runtime.input.getKey, and then ut.core2d.keycode.a. If you're pushing the A button, we'll want the input.axis to have a negative x. So we'll say input.axis equals new vector 2, -1, and then you could put 0, but maybe later down we'll want to do something with the y-axis, and we don't want changing the x-axis to interfere with that, so we'll just put input.axis.y. Now copy this and paste it, and instead of A, we'll be looking for the D key, and if we are pushing the D key, we'll want a positive axis instead of a negative axis. We'll actually make this an else if and not an if, and then if neither of those are true, we'll make the input's x-axis 0. Now, while we're here, we can go ahead and say movement.direction equals input.axis, and then movement.jump is equal to ut.runtime.input.getKeyDown, and our jump button is going to be the spacebar, so ut.core2d.keycode.space. Now, whenever we push the space button down, it'll make movement.jump equal to true. Go ahead and save your player input system, go back into Unity, and we'll create our next system, which will be the movement input system, or just movement system. Go ahead and open up the movement system, and inside of here we'll say this.world.forEach, and the components we'll be looking for is a ut.entity, a game.movement, ut.physics2d.velocity2d, then a ut.core2d.local transform scale. Then we'll name these as entity, movement, velocity, and scale. And inside of here, we'll say if movement.direction.x is equal to -1, if we go back into our input system, we'll see that our movement.direction will always be equal to our input.axis. So we can just put here, let set velocity equal new ut.physics2d.setVelocity2d, and then we'll say set velocity equals new vector 2, and we'll do a negative of the movement speed, and then the current velocity is y, Then we need to set this to our entity. So this.world.addComponentData onto the entity, and the data we want to add is the set velocity. So we'll be creating a new velocity 2D. The velocity 2D's velocity will be the negative of the movement speed. The velocity's y stays the same because if we are in the middle of a jump or if we are falling, we don't want to change the up or down movement of the y while changing the x movement. Then, after creating the velocity data, we just want to add it to the character. And at the add component data, how this works is if there is already a velocity component on the entity, it'll update the data of the component and not add a duplicate component. Now we'll want to do the same thing as this, but if our movement direction's x is 1, we'll want a positive x movement. And then, if we're pushing the jump button on the player input system, which will make movement.jump equal to true, we'll want to do this, movement.jump. So if movement.jump is true, we'll let impulse equal new ut.physics2d.addImpulse2d, and then impulse.impulse will equal a new vector2 movement.direction.x, and then movement.jump force. Now that we have our impulse 2D set up, let's add this component data to our entity. So this.world.addComponentData onto the entity, and the data that we want to add is impulse. So when movement.jump is equal to true, it'll add a upward movement impulse to the entity. Now one other thing we'll want to go ahead and do is on the player input system, we want this to run before the movement system. And to do that, you can say at ut.execute before ut.shared.input fence. So this file will always run before the input fence, and then on the movement system, we'll make it execute after the input fence, before the user code starts, and then on the movement system, we'll make it execute after the ut.shared.input fence. Then we also want it to execute after the user code starts, but before the user code ends. So execute before ut.shared.userCodeEnd. So what this is doing is saying this file should run before an input fence, this file should run after an input fence, but it should also run after the user code starts, but before the user code ends. The reason we are doing this is because we'll have another system called an animation system that will run after the user code ends, and the scale system will also run after the user code ends. This will ensure that any other systems that may interact with the character's scale or direction or movement will make sure to be updated before the animation or the scale is actually set to the player. So now that we have this set up, we can go ahead and play our game and see if our character is moving left and right and is able to jump. I think we forgot to set a movement speed on our character. Looks like that is true. Go back into here. Go to your player, set speed to 5 and jump force to 5. Go ahead and click play again. And you can see when you push A and D, your character moves left and right. When you push space, he'll get some upward movement. But when you let go of A and D, your character does not stop moving. Let's go see why that is. Going into our code, inside of our movement system, we need to make this an else if, and then say else if our movement.direction is not -1 or 1, it's probably 0. And inside of here, we'll say the same thing as this, but instead of movement speed, we'll put 0. Go back into your Unity project, click play. Now you can see when you let go of the button, your character stops moving. So the next thing we'll want to do is add in animations in the scale flipping. Go back into your Unity project. The way that we'll be setting the animations up will be putting the animations on new entities underneath the player as childs. So we'll remove the sprite renderer from the parent object. We'll go into the components. We'll create a new component called animations. On this component, we'll add 2 entity references. We'll call this one idle. We'll add another entity reference, call it run, and then put your animations component onto your player. Now on your player, right-click it and create empty child. On this, we'll call it idle animation. And then on the idle animation, we can turn off the local position, the local rotation, and local scale. Add a tiny component, the sprite renderer. On the sprite renderer, re-add the idle position sprite. Then we'll re-add the layer sorting with a layer of, was it 7? Let's check to make sure. Background is 4, platform is 5, foreground is 7, so our character is 6. And then to get the animations to play, you'll need a sprite 2D sequence. And we'll add 4 sprites to the sequence. Go ahead and drag your first 4 sprites from the graphics folder into the sequence areas. Then we'll want this to play at 6 frames per second, or at a frame rate of 6. You can change this if you want, but 6 seems good for me. Then we'll add a Sprite 2D sequence player to actually get this Sprite 2D sequence to play, and then make sure to drag in your idle animation into the sequence reference. We'll put the speed at 1, leave loop on loop. Now we'll duplicate this and create a run animation. So rename idle to run. And then the run animation is going to be 6 frames. So add a 4 and 5. And then your run animation will start here and it'll be the next 6 frames. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Looks like we missed one. Let's re-add these. 1, 2, 3, 4, 5, and 6. We already have the run animation dragged in correctly and speed on 1. Now disable your run animation and just have the idle animation enabled. So when you click play, you'll see that your idle animation is playing and the run animation is disabled. There we go. And you can move around while doing your idle animation. Alright, so the next thing we'll want to do is make the run animation play when you're moving and your flip scale to change when you're moving. First, let's do the flip scale, then we'll do the run animation. So go into your scripts folder. We'll create a new system called a scale system. Go ahead and open that file up. Inside of this file, we'll say this.world.forEach. We'll be looking for a game.flipScale, a game.movement, and a ut.core2d.transformLocalScale. What we'll want to name these is going to be scale tag, movement, and scale. Now inside of this system, what we're going to do is say scale.scale is equal to new vector 3. The x is the scale we'll want to change, so I'll just put a 0 for now. We'll leave y at 1 and z at 1. So on our scale.scale for the x position for flipping the scale, when our movements.directions.x is equal to -1, we want the scale to be equal to -1. If the movement's directions x is equal to 1, we want the scale to be equal to 1. But if you're not moving, your movement's direction x will be 0, but we do not want our scale to go to 0. So instead of just putting movement.direction.x right here so that it is always the directions x, we'll say movement.direction.x equal to 0. Then we'll put a question mark, which will let us say if it is equal to 0, we want to leave the scale at whatever the current x's scale is. If movement's directions x is not equal to 0, we'll want to put the movement.direction.x as the value that we want to be moving the scale by. Alright, now as I said before, we want this system to run after the user code ends. So say @ut.shared.executeAfter, oops, my bad, ut.executeAfter, then ut.shared.userCodeEnd. This will make sure that the scale system runs after the movement system, because the scale system will not execute until the user code ends, and the movement system executes before the user code ends. So we can go ahead and save that, and we'll create a new file called an animation system. So create tiny TypeScript system animation system. Go ahead and open that up, and in the animation system, we'll type the same thing as we have here, the execute after user code ends. Then inside of the animation system, we'll say this.world.forEach. we'll be looking for the components of game.animations and game.movement. And then we'll name those animations and movement. Then inside of here, we'll say if movement.direction.x is equal to 0, we'll set idle to be enabled and run to be disabled. Now else, if movement.direction.x is not equal to 0, meaning it's going to be 1 or negative 1, we want the run animation to be enabled and the idle animation to be disabled. So for enabling and disabling, we'll actually go back into the Unity project and create a new file called game service. So game service, open that file up, and inside of here, we're going to get rid of extends UT component system, remove the on update, and instead we'll be having a static set entity enabled. So we'll be making a static function called set entity enabled. Inside of this function, we'll be asking for a world, a entity, and an enabled boolean. Then in this function, we'll say let has disabled component equals world.hasComponent entity and ut.disabled. So if the entity has a disabled component, we'll have has disabled component be equal to true. And then if enabled and has disabled component, we'll say world.remove component entity ut.disabled. So if we're trying to enable the component by having the enabled boolean true, and it has a disabled component, meaning the object is currently disabled, we'll remove the disabled component, setting it to enabled, setting the entity to enabled. Now we'll say else if we are not trying to enable it and it does not have a has disabled component, we'll add one, world.addComponent onto the entity. The component we want to add is ut.disabled. Now that we have our set entity enabled function set up, we can go back into our animation system. Inside of here, we'll say game service dot set entity enabled. The entity or the world is this dot world. The entity is animations dot run, and the state will be false. Now copy and paste that, name this idle, and put this as true. Then copy and paste both of these, put it inside of the else, change the false to true, and the true to false. So if movement.direction.x is equal to 0, run is false, idle is true, else run is true, idle is false. We'll save, go back into our Unity project, make sure everything is set up. We need to drag our idle and run animation into the entity references. Go ahead and click play, and let's see if everything is working. You'll see that we fell. We're doing our idle animation. If we click D, we switch to the run animation. If we click A, our scale flips the other way and we run in the other direction, and we can push space to jump while running. Now, we still need to make him play the jump animation when you push jump, and also, you'll notice if you keep pushing jump, you can keep jumping. So we need to add a few more variables to fix these few things. But that will be in the next video. I hope you enjoyed this video. And right now we kind of have a superhero Flappy Bird game. This could be pretty fun if you want to play around with this. We've learned how to use tile maps, physics, and colliders. You could easily create a superhero Flappy Bird type game with the system that we've currently created. But until next time, have a wonderful day, and hopefully you'll tune in for the next video where we do jump animations, correct jumping to where you can't double jump unlimited amount of times to fly off the screen, and a few other things. Until then, have a wonderful day.